multiplying and dividing radicals, and I split it into two groups. The first part, I guess, is multiplying, and part 2 is going to be dividing. Do you have a part 1 and part 2 on your homework check again? Is there a part 1 and part 2 on there? There isn't? Okay, so when we go to do the homework, make sure you're only doing multiplying when you do part 1. Homework only go up to as far as there's multiplying, and then wait to do the dividing ones. Okay? Alright, so multiplying radicals. It is very similar to how you would multiply variables. If you had to multiply 8x by 6x, what would this be? 48. You multiply the numerical pieces together, and you get 48. And then you multiply the variables together, and you get x squared. Good. So remember, in the last section, I was kind of relating a lot of what a radical is to being how we treat our variables, too. So if you have a 8 with a radical getting times with a 6 with a radical, it's still going to be a 48, but then both of these items get times under in your radical. And that's all it is. Okay? Now, they have to be the same radical. So it has to be a square root with a square root, or a cube root with a cube root. If one of those was a square root and the other one was a cube root, you can't put them together. Okay? Also, when you put them together, this number under here might end up being quite big, and then you might be reducing it again. So we do have to do our reduction afterwards again and simplifying of our variables. Okay? Let's just take a look at these ones. So these look like they're bigger than we have had before, but really this is a monomial kind of variable expression times by another monomial. If you don't remember what I mean, this is a monomial. It's a one-piece item. This is a monomial. It's a one-piece item. There's no adding subtracting in it. So monomial times monomial, it's just the coefficients get times, the variables get times. So that's what we have here. We have no addition or subtraction, no addition or subtraction. So the numerical values out front, I call them the coefficients, those get times, and then the radicals get times. Okay, so when I go to do this one, the answer would be 3 times 4 gets multiplied together, so that's a negative 12. And then under the square root, my two radicands get multiplied together, so 2x times 6 would be 12x. Good. Okay, then I do have to now reduce. So I look at my radical, my radicand, what perfect square fits in there? 4 fits in there. Good. So I keep the negative 12 here, but I go a square root of 4, a square root of 3, and a square root of x. Okay? Or I could have kept the 3x together. It's fine. Okay? And what's the square root of 4? 2. Good. So I have a negative 12 times by a 2. And then these two can go back together, or maybe you kept them together to begin with. This would be a negative 24 square root of 3x. And then I check. They did tell me that x had to be greater than or equal to 0. Is that still true? Because it should be. Is it still true? Yes, because x can't be negative under there because you wouldn't be able to square root it. Okay, so x is greater than or equal to 0, and x is now the degrees. Good? Okay, let's take a look at b. b is 7 cube root 3 multiplied by 5 cube root 5. Sorry, I keep saying cube root. 7 square root 3 multiplied by 5 square root 5 minus 6 square root 3. Okay, now this is a little different. It's a monomial right here, and this is a binomial inside. Monomial is 1, binomial is 2. When you times things together, 1 times 2 is 2. You're going to have 2 arrows going in. So we're going to have to do this and this. Okay? The first one, when we multiply 7 square root 3 times 5 square root 5, multiply the coefficients out front. 7 times 5 is 35. Multiply your radicals underneath. 3 times 5 is 15. Good. So the first one's done. Now the second arrow. Multiply your coefficients out front first. 7 with the negative 6 is a negative 42. And then the radicand. Square root 3 times square root 3. This is interesting. What's 3 times 3? 9. What's the square root of 9? 3. So this is going to reduce down. So here's a couple things I want you to think about. I'm going to put a 9 here for now, because that's how we did the question. But in the end, you know that this is true. That if you had something squared and square rooted, this would cancel and you get a 3, right? Agreed? But the other way around also works. If you had a square root 3 and you were squaring it, that also works. And that's what you have. You have a square root 3 times a square root 3. So lots of people will still multiply out, put square root 9, and then evaluate it. But if you already knew that it's, hey, square root 3 times square root 3, that's just a 3, you could write it like that if you wanted to. Okay, for now, I'll just leave it here as a square root 9. Okay, next thing I do is, I can't combine these because I have square root 15s and square root 9s, and those are not like terms. I will try to reduce my radicals to see if they can become like terms. Is there a perfect square that divides into 15? No, so this one stays the same. And I'd probably ask myself the same question over here. Is there a perfect square that divides into 9? Well, actually, 9 is the perfect square. So this is 42 times 5, 3. Okay, and then throw that into your calculator. And what do you get when you do 42 times 3? 126, so negative 126. And this is the answer here, 2 here.